In this project, we want to detect fruits from images. The dataset contains 100 types of fruit images. Each type of fruit contains 400 pictures. We choose this dataset because it's complex enough. It not only contains pictures of various backgrounds for fruits, but also contain images of different parts of fruits, like fruit pulp or half-cutted fruits. Also, the test data is totally spoiled.
Hello, I'm Steven, and I'll be talking about how we wrote our code. So, we decided to mimic what we did in the homeworks using Google Colab. It could have performed better running on our actual computers, but it would hog it down. The take up the GPU wouldn't really be able to use the computers. So we had to work around how Google Colab works, and that made us upload our zip file of all our data to the drive, and then extracting it by tying our Google Colab to our Google Drive account. And so this is what that code does. And then we pulled the data. We needed to make a custom class because our data was formatted really weird, 100 different classifications, folders inside of folders. And so we made a custom class that would organize the data, label them correctly, and then get them in a nice format for our loaders. Setting up the transforms. We learned in the homework that doing just the regular default transformations made really bad models. And so we took up the same methods as what we did in homework, like question 7. We used like data augmentation to prevent like overfitting. That's what the resize crops and the flips are doing. And then we needed to resize the actual files because they were not consistent with each other, which was really annoying. So we changed them to a 224 by 224, which didn't lose too much information, but we didn't go all the way to 32 by 32 like the homework did. And then also there was a difference between our model from scratch and the pre-trained model. The pre-trained one, we gave it a different standard deviation and mean, which made it perform better, but that was just because the pre-train takes way less time. So doing that with the other one doubled the time it needed to run, so we canceled that because that was too long. So, and then these are just creating the data sets and the loaders from the custom class we made. And we used a batch size of 4. We would love to use something different, but again, these taking so long made it impossible. So we went with the default there. And then creating that on the left, you can see the 2 convolution layers, 3 linear ones, and the ReLU just like in the homework, and that performed pretty well. But on the right, we were told, hey, you might want to look into pre-trained models. But we wanted to compare both of them. We didn't just want to do one. So someone said RexNet. RexNet looks really good. So we tried that, and I'm really glad we did. These experimentation results gave us some information. So you can see here that on the left, this was 5 hours for our net from scratch, and the loss is terrible. A 16% accuracy seems terrible, but since we have 100 different classifications, that's like 16 times better than guessing. So it actually is really good, but 5 hours of training is not enough. On the right, we had 1 hour of training on the pre-trained net. Already starting off, it was doing really good, and then we shaped it a little bit with our giving it our data set, and it performed really well with only an hour. So we probably could get those results if we've spent 100 or thousands of hours of doing training on the one on the left, and maybe even a bigger data set.